Okay. So I'm Paul Coggin. I'm from Huntsville, Alabama. Work for a company called Dynetics, where I'm a network security architect, focusing on critical infrastructure. I design, secure, and figure out how to break into critical infrastructure. Various organizations. Background is in everything from transport networks, DWDM, MPLS, core routing, network management, etc. So we got a hardcore network infrastructure background, working in the telco utility cloud. And so what this talk is about is, you hear all about in the news about the advanced threats to critical infrastructure, all the talk in Congress, et cetera, these days, about all the cyber legislation. And so I came up with this presentation as a result of all that to clear up what's really going on. These guys are getting hacked out at the spokes, your municipals, your independent phone companies, your RLECs, et cetera. They're getting popped, and it's basically because of the trust relationships and the interdependencies that they have. And it's not really an advanced adversary. It's required to get into these networks. It's just the old school basics is enabling. And so I'm going to share some war stories, real world attacks, of what's happening. So this is an example architecture of the networks that are being rolled out, the next generation networks for service providers and utilities. The utilities are rolling out smart grid, and in cases where they roll out smart grid with fiber to the meter, since they're rolling out fiber, they've got a great deal of bandwidth available to them, so it makes sense to offer additional services. So the utilities are getting into the cable TV, voice, internet business in many cases, in addition to smart grid. And then the telcos are also getting into the cable TV business, and all of them are getting into cellular backhaul, of course. And depending on the which vertical it is, whether it's utilities or the telcos, you might have a little bit different architecture, but they're all going to have a operating support system, an OSS, and BSS, business support system infrastructure that I have represented at the top, where you have the network management, the provisioning, your support for lawful intercept or wiretap, so that when law enforcement needs to do a wiretap on somebody, that capability is in place. That has to be up there at your top layer. You're going to have, if it's a utility, you'll have the SCADA systems that are integrated with the business support systems, enterprise networks, and along with, say, middleware for the cable TV. And then you move down into the middle of the drawing, where you're going to have your transport network, where it's going to be your optical backbone. Could be a DWDM, dense wave division multiplexing network, where you're splitting out light wavelengths. Could be some old legacy SONET TDM infrastructure, or it could be mostly the next generation MPLS IP type core network. And then you ease down into the access network, where the particular organization may roll out passive optical network, or they may be rolling out an active Ethernet network, and then at the same time supporting some legacy TDM, DWDM, SONET network infrastructure out to their services. But the one thing it has in common is all those different layers and all those different systems that are represented, that's all a different vendor. And all of those vendors want remote access into these critical infrastructure networks. So every time one of these organizations roll out one of these new next generation networks, they're getting not only numerous truckloads of equipment, they're getting a whole lot of vendors, and all those vendors with all their technicians want to be able to remote in. What the big problem I'm seeing is that the organizations that are buying into this do not have any kind of security policy in place that is going to define how it gets implemented, so that there's some consistency amongst all the different vendors. They're just, whatever the vendor wants to do, they're letting them do it. And I'm going to show you some results of it. This first example, we'll get into some SCADA examples. The drawing on the right, that diagram, comes from the ISA organization. That is the ANSI ISA 99 architecture. This is the international standard for how SCADA networks, whether you're an industrial control system or if you're a power utility. This type of architecture that they recommend, where you have segmentation with firewalls between the different layers, from the enterprise all the way down to the process control, where you actually have real machines and physics happening down at the bottom of the drawing. That's a real nice drawing. Somewhere somebody's probably implemented this architecture. I've not yet seen it. What gets put in place in reality is where you see firewalls. In many cases, it may be an XP or even a Windows NT 4.0 box with multiple Ethernets in it. And that's segmentation and that's security. If you don't believe it, just ask the organization. They'll tell you it's secure because my vendor told me it was. Other examples of what we're seeing reality versus what is recommended by the International Standards Body is I was just in a utility not too long ago troubleshooting a Metro Ethernet problem for them and got into their firewalls. And you just can't make some of this stuff up. Look at their firewall. Their billing system vendor, who provides the cloud. You can trust these cloud vendors, right? Well, they outsourced their billing system, and the cloud vendor dropped in firewalls for them so that they could get out to the internet securely. Permit any both in and out. The only thing protecting that utility was the PAT. They did not have a static NAT translation. After I picked myself up off the floor after seeing that config, because I'd never seen anything like that, and I went and asked the operations manager, "Would you show me your how you get into your SCADA system?" Because I started getting really scared. And he's like, "Oh yeah, that's on a totally different, separate network. We keep that separate from the business network." I was like, "Well, show me what you got." Faster than my eyes could keep up with, he had his Android phone in my face with his SCADA system. VNC, no VPN, no password to the phone, no password to the VNC, no password all the way to his SCADA. That's clear. That's what's happening with SCADA real world. But they just need to be, it's all voluntary. They're going to implement it out of the goodness of their heart. They're going to secure all of this. And I tried to go and talk to this guy about security, and he wouldn't have no part of it. He said that was secure, that they could log right into his phone with no password anywhere in the process and pull up SCADA. So here's an example of a telco architecture. You got the transport network where you got DWDM, maybe have MPLS, Ethernet running over wavelengths, lambda wavelengths, and for the transport network, and then could be a SAW switch thrown in, where the SAW switch, if you've got a Cisco Call Manager or some of the other voice over IP systems, basically a SAW switch is a regional city, large footprint scale version of, say, Cisco Call Manager, and we'll call it a Class 5 switch. And it's and when you get into Class 5, that's what say the AT&T, Bell South of the world run. And you basically can consolidate a room full of Class 5 legacy equipment down to a very, like a half a rack, and they'll roll these things out. But what happens, and what's important to take away from this, is whether it's a transport vendor or a SAW switch vendor, whenever they go and roll in their system, they want remote access. And we've seen on numerous occasions already where they're putting in a multi-home Linux box, sometimes behind the firewall, sometimes bypassing the firewall, with a wide open surface of attacks with no ACLs, so that anybody that can find that SSH port can sit there and brute force at will. And there's no account lockouts. They just find the open account and they just keep hitting it until they get in. And on numerous occasions, we've been called to find out that the SAW switch or the what we call an element management system, which is the network management system, is specifically designed for a hardware component, where that system has been broke into. And the only reason they found out about it is some bank in Europe called them and told them to cease and desist. Otherwise, they'd never known that a core piece of this critical infrastructure had been taken over. Now, if an advanced adversary got a hold of it, who knows what they could have done? They could have took out the voice services, like 911 dial tone to your home, or taking out the whole network infrastructure. And here's an example. This is where I start. The vendors are putting these things in, just like that previous chart. A billing system vendor again here put in an architecture for a telco who is also providing services to utilities for smart grid now. Make you feel better. But not only are doing all the voice, video, and internet, they're also supporting smart grid. And the billing system vendor put in a system for them. And being the brilliant security people they are, there's no DMZ. The external web server that online bill paying happens on sits on the internal billing system. So you go straight through the firewall and interact with the crown jewels and their network. So they brought us in to do a security assessment because they wanted a insurance break. If they got a security assessment, they could get a break on their insurance premiums. And so we went and did a security assessment. They got more than they wanted. We ended up not only finding a bunch of directory traversal opportunities on their Apache server, we were able to get some shells. And through those shells, because of those trust relationships between that billing system and the automated provisioning, so when you go online, if you pay your bill, services keep working, or if you want to subscribe to new services, you can order those services off that website, and then it will go and kick off scripts that talk to systems up there in the upper right corner, and where automated provisioning can happen end to end without having to do a truck roll or somebody having to get out and do punch down services. It's all automated with dynamic network management. Well, by way of getting into that system, we could exploit trust relationships and end up taking control of the whole network. We had to stop there because we'd already captured everything. There was no reason to go further. What's really bad though, in the case of this vendor, we went and showed all the screenshots of how we got into the network and had complete control of the whole not only the enterprise but the whole overarching infrastructure. We lost the argument, even though we had pictures. The billing system vendor said we were wrong and that they were secure. It's something, us techies in the security industry, we got to get a business conversation, because the business guys, they talk money. They get the bills paid for the telco. They help cut the checks. They won the conversation. Dollars win, and so now the billing system vendor who put this architecture in place is in the security business. They perform security assessments so that if you want an insurance break, you just come to them, and they will test the network that they put in with no DMZ segmentation, big flat networks with all the hosts, so that you can get your insurance break. It's real secure. So here's an example of there's no insider threat. That's what we always hear. If you talk to an organization, those statistics prove differently. This happened in an incident happened accidentally, but could very easily be someone that was mischievous, say a disgruntled employee, similar to what happened to Cox Communications a couple years ago when they tried to fire a router guy. And he started shutting down equipment. In this case, there was a technician. He had access to the core transport and access networks, and he was going to go provision some new services. And the vendor that they chose to provide the core transport network for them, they implemented multicast in their hardware, so that if anything got put into this particular VLAN that was designed for video, that it would break the RFCs for multicast, and it would automatically replicate that traffic for speed. And the reason they did that is because they were going to run IPTV, and that's what the customers typically for this core infrastructure would do. They'd get into the IPTV business, and the whole point was when somebody started changing channels at home and started changing TV channels, those TV channels are mapped to IP multicast groups. So you want it to happen very, very fast. So they tried to get everything implemented in the ASICs. And so they had different VLANs for voice and internet, et cetera. Well, in this case, the technician provisioned internet denial of service infected malware subscribers over to that video network. As soon as that traffic got provisioned over there, the transport network rolled over because it started doing denial of service against itself. And luckily they had instrumentation visualization tools on the network where we could do full PCAP and see net flow of what was happening. And it's the craziest thing, if you're used to looking at PCAPs, I've never seen this before, but they had IGMP encapsulated in ICMP, and that's some crazy packets. I wish I would have got some packet captures to show you guys, because you'd have to see this IGMP layer 2 encapsulated in ICMP, craziest packet. And the guy was reading this to me. I was on the interstate, had to pull off on the side of the road to help him troubleshoot this, and the guy was reading this packet to me, and I'm like, what in the world? But this gets back, to having real good configuration control, and like I said, an adversary could easily just roll this over, or somebody that was disgruntled because of the lack of security controls. Here's a problem that was in the news pretty big here recently, with Brazil getting 4.5 million routers popped. We identified this problem a couple years ago, earlier, before it happened. And what it comes down to, it's just the basics again. They had no separation of services between the management plane, the control plane, and the data plane in the network. What's happening here with this screen? This computer's trying to slide. I think it's coming back up. There it goes. Sorry about that. But sorry about that. But what happened is because they had no control management and data plane separation of services, someone in another part of the world started targeting the DSL routers. Apparently, they knew about some backdoor passwords that the vendors didn't, the end users didn't know about, and these guys did. And one customer, they had tools on the network. They were able to catch it before right around 600 routers. Another one didn't have any tools to capture problems, and it was about 6,000 routers later before they caught the problem, just because they did not go and control the management plane of the network. Very basics. And then here recently we've seen a similar problem pop up where the routers were being DOSed and being just killed by an attack that's happening. In this case, what we saw was the routers were being reconfigured so that they allocate a DNS that will redirect traffic to some rogue DNS servers so that a man-in-the-middle attack could be performed, so that they could do basically a DNS farming type attack, more than a man-in-the-middle really. And here's another issue we've seen with vendors dropping in these systems. Wherever these telco head-ends are being put in some cases, the vendors are wanting a nailed-up VPN. Some of them will suffice with an SSH or VPN client, remote access, but a lot of them want a nailed-up dedicated VPN, firewall to firewall, router to router. And what we've seen in one case is we were on site working, and one of the vendors just showed up out of nowhere, unannounced. Just showed up out of nowhere and started ripping the system out. And what we discovered, because I started social engineering the technician, figure out what was happening, because nobody expected it. What turned out is back up there at the upper left at the vendor location, they got hacked, and it appears that somebody pivoted off of them and attacked their customer, and they knew it hit that system, and then they go and pull it out. I don't know how many systems they had to go pull, but I did see that one, which led me to a question of knowing things about the trust relationships and how these networks are wide open. They got a flat earth policy, typically, with no segmentation. If you can get in, you can see everyone and pivot at will horizontally. How much easier would it be with all these vendors that are putting in these backdoor VPN connections for remote access? How much easier would it be to go and pop one and then pivot back to other vendors and then turn around and pivot off those vendors to all their customers? I mean, if you got an adversary that's thinking and thinks strategically and not just wanting to go pop boxes to go send spam, but has a more strategic vision for what he can do. I haven't seen this, but I have to think that somebody's thinking like that, because if I am, somebody a whole lot smarter than me is probably strategizing around this. And then it could be very easily stopped by just locking down the segment these networks, and lock down the need to know and the access. And in one of these locations we went into where the firewall was put in, we actually saw the firewall in front of this utility put in reverse so that the internet was protected from the customer. That was amazing. That was amazing. I mean, the firewall had a nice GUI and everything. I mean, it's like, dude, really? But hey, they paid for it. So I call it the vendor persistent threat now, the VPT. So the big issues that we see prevailing across all this critical infrastructure, regardless of where we go into, anybody with any basic skills that's watched a YouTube video they'll take them more time to boot their laptop than to own these networks. The layer 2 issues are prevailing. Any of the layer 2 protocols, the ARP poison problem that has existed since the 80s, it always works in these networks. If you've got a better understanding of the first hop routing protocols, or the first hop redundancy protocols like VRP, HSRP, GLBP. All if they're in place, you can easily go and pop those. Uh, the spanning tree, you could just go and own these networks with Yersinia if you can get access. And the bad thing is they got the knobs typically there to turn to secure these networks. They pay top dollar for the Juniper Cisco, so they could secure this. It's just the vendors having security for them. Bottom line takeaway: everybody's talking about the application host-based whitelisting, but I'm becoming more of a big advocate, especially with this critical infrastructure where it's very deterministic. You know who should be talking to who, and you know when they should be talking, the volumes of traffic, time of day that they can be communicating. Why can they not go into these SCADA systems or these telcos and lock down very granularly who can talk to who and when and on what parts and services, and then log anything that breaks out of those bounds instead of all these big layer 2 flat networks, and even if they have VLAN segmentation where it's just open, where there's no ACLs controlling the trust interconnections between them. If we went and locked that down and then monitored that, violations of that, we could catch violators very, very quickly and solve a lot of these problems with our critical infrastructure without spending. We've already spent the money in many cases. They already have the top of line infrastructure. It's just not configured. Sure. Okay. What's that? Yeah. Right. My understanding is there. My understanding there is no logical connection between the spokes and the upstream generator. That's what I've been told, and I don't know any different because I've not worked at that level where they're under NERC and PERC regulatory regulations. If you start dealing with the power generators earned, they're very strict regulations and they got huge budgets for security. But at the spoke level, what my concern is because of the desire for being able to automate provisioning. You pay your bill, your power stays on. You don't pay your bill, power gets turned off. If you want the power turned on, you just go online, pay your bill, and they automatically turn your meter back on. Gets rid of the truck roll. My concern is because that kill chain that goes from that online billing system all the way to that SCADA system, all the way to these smart meters. How easy is it going to be if you figure out the vendors that are rolling out these systems and the poor architectures that are being put in place, including the bad code, no telling what kind of holes are in their code. Uh, how easy would it be go to script or just throw bodies at knocking out a large number of municipals and telcos and taking down that infrastructure? You might not take out the generator, but if the generator's customers are not there, if you're not taking the same effect, I mean, right, 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 right. I don't know enough about the power system to know what's possible in that realm, but I just worry about somebody going and targeting the spokes because that's the soft underbelly. And right now, with all this critical infrastructure, right now it's the regulatory the legislation that's being pushed through right now is all voluntary. There's no hammer, and I think we as a country have got to get a hammer. I mean, I'm not into government meddling in our business, but if you're going to be in the critical infrastructure business, you need to take some responsibility and do due diligence, not just worry about getting an insurance break, but really do something. Right, right. Even if you get out to the spokes, it doesn't matter what size the spoke is. If you're buying services, you're probably buying. Everybody's buying from the same vendors. You know, and vendors do the same thing over and over and over again because they got to be able to manage it. It's got to be able to scale. So if you can find out how the vendors are rolling out their remote access, or you can find out through LinkedIn or whatever who are the vendor technicians that are rolling these systems out, pop them, fish the vendors technicians, piggyback on them, and get right back into the networks, and then from there you could go and develop an attack tree to knock out a large number of vendors because they're all going to do it the same. It doesn't matter if it's a city of 1,000 or a city of 100,000. The vendor's going to do it consistently. They build in backdoor passwords and hard-coded passwords into their client-server relationship. It's going to be everywhere. They couldn't manage it otherwise. What I've seen is that my experience, it's pretty cookie cutter. If you go into one, you've seen them all when it comes to the vendors. Unless you get into a mature organization that has top-down driven security policies, and they write into their RFPs that whoever the vendor is going to adhere to these standards, you're going to see the same thing over and over and over again. Because what I see with the vendor responses is this is the access that we require, and we're going to have this access to our soft switches and our infrastructure, because we know that when we drop this new next generation network on you, you're not going to know how to manage it. I mean, unless you've gone and hired a team of really good network engineers and security engineers and system admin, they're not going to know how to run all this. So you're going to have remote help to keep it all operational. They don't want to spend the money, and they don't know. And the vendors will, if you go in and do an audit, the vendors will argue with you to tell you that that it's all mitigated. They're just throwing FUD out. So what I see is we're really going to have to get into something where we've got a regulatory hammer to force it to be fixed. Some of them will get proactive, but a lot of them they really don't want to hear it. Well, if they're doing service provider, most of them, if they're of any size, are doing BGP, so they own their blocks. So they've gone, in most cases, they've gone to Aaron and they've registered IP space, so they can do multi-home BGP. Right, right, right. So you can find them pretty easy. It's very rare nowadays that any of them don't have their own IP space. There was a period. There was a period up to about 8 years ago where you might find an organization that might be single home and didn't have BGP, et cetera, but you won't see that anymore. They all got their own space. I appreciate it. Thank y'all.